story that you may have heard what the answer is. The story goes something like this. Once upon a time, humans used to think they were pretty special, that they were the center of the universe, and that things kind of revolved around them, and that there was a God who cared about them. But then Copernicus came along, and Copernicus said, you know, the Earth is not the center of the solar system, the sun is, and it seemed to demote humans from a central place in the universe to some distant planet in the universe. And then Newton came along and said, you know, maybe we don't even need God because the universe is run by laws. And the laws of physics tell us how the universe works, so, we don't need a God because everything works so well. And then Darwin came along and said, not only do we not need God, but humans seem to be insignificant in and of themselves because they're just the product of random mutation and natural selection in this process that accidentally spit humans out. And that is the story that we often hear that science tells about God in the place of humans. There's a couple problems with the story. The first problem is that it's simply wrong. It's not the real truth. Here is a picture of what people thought the universe was like before Copernicus came along. And lo and behold, the Earth is at the center of the solar system, of the universe, and everything revolves around it. But the center wasn't an important place. The center was the trash heap. And people used to think that the celestial bodies, the moon and the sun, were perfect, spherical, wonderful, heavenly objects, and the earth was the garbage heap of the universe, which is why everything fell to the center of the earth. But not only was the earth the worst part, but at the very center of the earth, the closer you got to the center, the worse it got, and at the very center of the earth was hell. And so when Copernicus said the earth is a planet that revolves around the sun, he didn't demote the place of humans in the mindset of the people. He elevated them. All of a sudden the earth became the same as one of these heavenly objects, which were somehow perfect and exalted, unlike the garbage heap earth. So that's one problem with the story. But the second problem with the story is that it's all old history. I mean, Darwin wrote The Origin of the Species in the mid-19th century, and we've come a long way since then. And the question I want to ask tonight is, what has modern science told us about the humans and God, place of humans in the universe and God? And I want to talk about three pieces of evidence that I think from modern science actually gives us evidence of God and gives some idea of what God is like. And those three things I'm going to talk about tonight are the origin of the universe, the design in the universe, and something called the rare earth. So let's start with the first one, the origin of the universe. And what we learned from science over the last 100 years or so is that the universe seemed to have a beginning in what we now call the Big Bang. About 14 billion years ago, everything we see in the universe came into existence. Space and time and matter and energy. Now, I don't know what it means not to have space and time. My waistline takes up more space than it's supposed to. I'm actually trying to lose some weight. Everything takes more time, particularly since I'm from Southern California. And the time I spend on the freeway trying to get from one place to another always seemed to be too long. So everything I know takes up space and time. But what we found is that the universe seemed to have a beginning, even of space and time. Actually, the word Big Bang has different meanings. Scientists use it in different ways. Tonight I'm going to use it in its original meaning, which was the very beginning of the universe. Now, until about 100 years ago, we had no idea whether or not the universe had a beginning. But in 1929, Edwin Hubble observed that the universe was expanding. Much like raisin bread, this is a little cartoon of raisin bread. If it rises in the oven, all the raisins get farther apart from each other because the bread itself is getting larger. And what Hubble noticed is that all the galaxies in the universe were getting farther apart. The universe is expanding. And if the universe is expanding, you don't have to be a rocket scientist. Well, I guess he was. But you don't have to be a rocket scientist to realize that if the universe is expanding, it must have started to expand. It must have had a beginning. The expansion implies an origin. Now, scientists didn't like this. They didn't like the idea that the universe might have an origin. When Hubble first came up with his discovery, Arthur Eddington wrote, philosophically, the notion of a beginning of the present order of nature is repugnant. I should like to find a genuine loophole. So why does he want to find a loophole? Because if the universe had a beginning, it might have had a beginner. And that idea is repugnant to many people. But nevertheless, scientists accept now that the universe had a Big Bang origin. And the reason scientists accept it is, even though it's repugnant, is because the evidence is overwhelming. And the evidence comes in three pieces. The first of one is what I've already said. The universe is expanding, so it must have started to expand. The second piece of evidence is the amount of hydrogen and helium and other light elements of the periodic table. In the first 3 minutes of the universe, hydrogen and helium were formed, and no other elements in the periodic table were formed. They came much later. We'll talk about that, and that will also be on the quiz. But anyway, we can predict exactly how much hydrogen and helium we should see in the universe if it started with a Big Bang, and what we see is exactly what we predict. The third piece of evidence for the Big Bang is the temperature of the universe. 14 billion years ago, everything we can see in the universe was compressed into a size smaller than an orange. And since then, the universe has been expanding and cooling. It started out very hot. So if you were to go home and for some reason, you're inspired to make raisin bread, I don't know why, and you turn on your oven, and you get the oven really hot, and then you realize you have no idea how to make raisin bread, so you turn the oven off. The whole house would eventually be a little warmer because your oven was first really, really hot. So if the universe started out really, really hot, we should see some leftover heat, like the oven's leftover heat. And in 1964, two scientists discovered what we call the cosmic microwave background radiation, the temperature of the universe. In fact, if you remember old television sets, analog television sets, if you turn them off, or if you turn them on but turn to a channel that didn't come in very good, you see all this fuzz in the background. Some of that fuzz is actually a signal of the temperature of the universe from the very origin. So all of the experimental evidence says the universe had a beginning, and not only the experimental evidence, but the theoretical evidence. Albert Einstein developed the general theory of relativity, which said that the universe should be expanding. His equation said that. But he didn't think that the universe should be expanding because Hubble hadn't discovered it, and it would mean the universe had an origin. So Einstein added a fudge factor to his equations called the cosmological constant to try to keep the universe from expanding. And when he realized that it was, he said that was the worst mistake, adding this fudge factor, of his professional life. In 1973, Stephen Hawking, George Ellis, and Roger Penrose took Einstein's theory and developed it further and realized that it predicted that time had a beginning. That not only space had a beginning, but time had a beginning. Then in 2003, three physicists, Alan Guth, Arvind Borde, and Alexander Vilenkin, BGV, Borde-Guth-Vilenkin, came up with the theory based on all the physics we know that says any universe that's expanding on average had to have a beginning. So what have we come upon? We've come upon the fact that this universe, everything we can measure, everything we know of physics with our equations say the universe had a beginning. So if the universe had a beginning, if everything in this universe came into existence, then the cause of the universe can't be part of the universe. The cause of the universe can't be the universe itself. It has to be outside of the universe if this universe had a beginning. This rules out certain worldviews like pantheism that says this universe is God because this universe had a beginning. And so only worldviews that have a transcendent cause, a cause outside of the universe, agree with science. And of course, the God that's described in the Bible is completely transcendent outside of space and time. And so science gives evidence for such a transcendent cause. Now, this is not just my idea. This is not just the idea of people who believe in God. Robert Jastrow was an agnostic physicist, didn't believe in God, but he understood the implications of the Big Bang. And he wrote this. He says, "For the scientist who has lived by his faith in the power of reason, the story ends like a bad dream. He has scaled the mountains of ignorance. He's about to conquer the highest peak. And as he pulls himself over the rock, he's greeted by a band of theologians who've been sitting there for centuries." Right? Because the theologians said all along the universe had a beginning. In fact, the things that science has learned about the origin of the universe were all predicted in the Bible thousands of years ago. Oh, this didn't turn out well. We took the slides from one form to another. So the first thing is that the universe had a beginning. The very first verse of the Bible says, "In the beginning, God created the heavens and the earth." I could have told you we would find a beginning to the universe because the Bible says there was one. We didn't know that, didn't find that till the 20th century. The second thing is that Hebrews says that the stuff of the universe didn't exist at one time. What you can't read says, "We understand that the universe was formed at God's command so that what is seen was not made out of what was visible." what we see wasn't made out of anything we can see. And that's true. We don't know where the universe came from, all this stuff. The energy, the mass. But it started 14 billion years ago. And then the final thing that we have learned, but that the Bible predicted, is that the Creator is not bound by space and time. Now, this is important. The New Testament is the only holy book in the world that explicitly talks about a Creator who acts before time began. Paul writes, grace was given us in Christ Jesus before the beginning of time. Other religions have an idea that God maybe created time or made time, but the New Testament is the only holy book that explicitly says that God is acting before time began. Scientists didn't even know that time began until the 1970s. But yet this describes that there was action before time began. So the origin of the universe points to this transcendent cause outside of space and time that exists. The second piece of evidence is the design in the universe. And I want to talk specifically, when I talk about design, of something called the anthropic principle. It comes from the Greek word anthropos, which means humanity. And it's the idea that the universe has a bunch of parameters that seem to be finely tuned to allow humans to exist. It's as if you have a control panel with 100 knobs, and those knobs control things like the speed of light or the mass of a proton. And if you change those knobs just a little bit one way or another, you either get no universe at all, or a universe that's inhospitable to life. This book, The Anthropic Cosmological Principle, lists about 100 such parameters. It's old. It was written in 1986, but it's still very relevant. It's a difficult book to read, but it's a really good book. If you really like reading like calculus equations, then you'll love this book. So then I would highly recommend it. So let me tell you, I can't list 100 things that are finely tuned in the universe. So let me just list 2 or 3 things to give you some idea of what this is like. The first thing is the strength of the strong force. Now, this is on the quiz. Atoms are made of nuclei, nuclei are made of neutrons and protons are made of quarks. And the strong nuclear force is the force that holds the quarks together in the neutron and proton, and holds the neutrons and protons together in the nucleus. And the strong nuclear force has a particular value, and we could try to change that value a little bit up or a little bit down. In fact, it's because the strong nuclear force has its particular value is why we have the periodic table. If you love chemistry class, you can thank the strong nuclear force, because the periodic table is there because of the strength of this force. Now, if I was to take the strong nuclear force and make it just 2% stronger, then I would basically get rid of hydrogen. If I took the knob that controlled how strong the nuclear force is and changed it 2% more, I'd get rid of hydrogen. That's a problem. Water is H2O. We'd have no water. Our sun burns hydrogen for fuel. We'd have no planet, no stars like our sun. If I was to take that same knob for the strong nuclear force and make it 5% weaker, then the periodic table, would look like, like this. We'd only have hydrogen. That would make chemistry class really easy. We'd all be signing up for it. But it make life impossible. So the strong nuclear force is finely tuned to allow any kind of life, any kind of universe. Another thing that is finely tuned is how carbon is made. So in the first 3 minutes after the Big Bang, hydrogen and helium were made, but nothing else, none of the other elements of the periodic table. So where'd they come from? Well, stars have a lifetime, like everything. They're born, they live for a while, and they die. And one of the things stars do when they die is they make carbon. And so the carbon in your bodies is the result of dying stars. You can poetically say we're all made of stardust. It's really quite cool. But the process of making carbon as stars die is very, very complicated. It has to go through a whole bunch of things called nuclear resonance states. I once tried to explain that to an audience like this. I was at Stanford, and Stanford students I thought were pretty smart. So I tried to explain nuclear resonance states to them, and everyone fell asleep. So I no longer do that. But the idea is if you were to change anything in this long series of events, it takes a whole bunch of events to eventually get carbon as stars die. And if you change anything about that series, you don't get carbon. One of the things is what we call the mass of the light quarks. So neutrons and protons are made of quarks. I've said that a few times. That's what I study, so I'm really thrilled about it. I know you don't care at all, but neutrons and protons are made of quarks, and the 3 quarks inside neutrons and protons are called light quarks, because their mass is not very much. They're light. So Dean Lee studied this process of making carbon in stars, and he says, we find that more than a 2 or 3% change in the light quark mass, those quarks that make up a proton, would lead to problems with the abundance of either carbon or oxygen in the universe. So every one of your protons, every one of your neutrons in your body is made of these quarks, and if I change their mass by 2 or 3%, we don't have carbon and oxygen in the right proportions to have life. One more I want to tell you about is something called the entropy of the universe. I know that sounds like a physics word because it is, but the entropy is in very rough terms a measure of how ordered something is. The higher the entropy, the less ordered it is. So everything in the nature, you've heard of the second law of thermodynamics maybe, everything in nature becomes more disordered. You know this because your room becomes more disordered. There's only one way for everything to be in the right place, but there's a million ways for everything to be in the wrong place. And the Big Bang was not some chaotic explosion. It was an extremely ordered event. Everything was exactly how it had to be to produce the universe we have. And the entropy, the order of the universe was extreme. The entropy was low, meaning it's extremely highly ordered. Everything's in the right place. Roger Penrose has calculated that the initial entropy of the universe was fine-tuned to 1 part in 10 to the 10th to the 123rd. I mean, that's a number that is so small, that probability, that you can't even imagine it. This is a real problem for people who don't believe in a creator, is how do you get the entropy of the universe at its beginning to be this small? I read a lot of people who don't agree with me. I'll talk a little bit more about the end, but Sean Carroll is a really brilliant astrophysicist who writes about the origin of the universe. He's an atheist, and he even says this is almost a problem that we can't solve. He says that there are about 5 different theories on how the universe began, and 4 of them we can't even begin to look at because they don't solve the entropy problem. So what does that mean? Well, I've listed just a few things about the universe that seem finely tuned to allow humans to exist, and scientists recognize this. Again, I love the fonts, the way we did this tonight. All right, it says, so John Gribben and Martin Rees write in Cosmic Coincidences, if we modify the value of one of the fundamental constants in the universe, one of those knobs, something invariably goes wrong, leading to a universe that is inhospitable to life as we know it. When we adjust a second constant in an attempt to fix the problems, the result generally is to create 3 new problems for every one that we solve. The conditions, get this, the conditions in our universe really do seem to be uniquely suitable for life forms like ourselves, and perhaps even for any form of organic complexity. The conditions are uniquely suitable for any form of organic complexity. The third thing that gives me evidence that there's some kind of God is the rare earth. So what I want to talk about when I talk about the rare earth is this question: what's required to have a planet that can support higher life forms? And by higher life forms, I don't just mean humans. I mean anything more complex than bacteria. Bacteria can live anywhere, but anything more complex, even the resilient cockroach that will survive the nuclear blast, even that is a complex organism. So anything more complex than bacteria. And of course, that there's life like us all over the universe, because you watch Star Wars or Star Trek, and we can debate which is better. But, there's lots of life forms out there, maybe. But the question I want to ask is, what's really required to have a planet like the Earth? The first thing is we have to live in a spiral galaxy. This is what our Milky Way galaxy would look like if we could get far enough away. The spirals you see are about 200 billion stars that wrap around the center like this. And there are only about 10% of the galaxies in the universe are spirals. To have complex life, you need to be in a spiral galaxy. The other kinds of galaxies, irregular galaxies and elliptical galaxies, don't have enough star formation or have too much radiation or other things to have complex life. And you can't be anywhere in the galaxy. If you're too near the center, there's too much radiation, and at the very center there's a black hole, which is not a good place to live unless you're in the movie Interstellar. If you're too far from the center, there's not enough star formation to make things like carbon and oxygen. So you have to be about 1/3 of the way out to 2/3 of the way out. That's called the galactic habitable zone. And our sun is, of course, right in that perfect spot in the galactic habitable zone. You have to have the right kind of star. There's so many things about the sun that make it unique. It's a class G star. It's one of the few stars that burn stably enough and long enough to have a planet like the Earth. It's a bachelor star. That means it doesn't orbit another star. Most stars orbit another one, binary stars. And those stars can't have stable orbits like the Earth because the gravity from one star perturbs the orbits around another star. It's also a third generation star, which is really an important idea. It takes the first generation stars were only made of hydrogen and helium. And those stars lived out their life, they died, they made some carbon and silicon oxygen, but not enough for a planet like the Earth. So the second generation of stars were formed. Some of those died. They spewed out their material throughout the universe. And our sun was formed from that generation of stars. It's a third generation star. It's the first generation of star, the first kind of star to appear in the universe that has enough carbon, oxygen, silicon to have a planet like the Earth. So Bachelor star, third generation star, class G star. We haven't found a star actually like it anywhere. It's unique in many characteristics that make it perfectly suitable for life. The Earth is perfectly suitable for life. There's a whole bunch of characteristics. Its mass, its rotation rate, its size, the amount of water on it, even tectonic activity. So I'm from California originally. I know what tectonic activity is. It causes earthquakes. And you might ask, well, why would God allow earthquakes? Well, it turns out that tectonic activity, the movement of the tectonic plates on the Earth that cause earthquakes, is necessary for a planet if you want to keep water on it. The movement of those plates allows water to not evaporate from the Earth. In fact, tectonic activity may be the single most important reason of why we have water on the Earth. Why do we have earthquakes? So we can be alive. So we can have water on our Earth. Without tectonic activity, that would not be the case. So even things we don't understand. I won't go into this, but the moon and Jupiter, our single large moon plays a huge role in stabilizing the tilt of the Earth. Jupiter plays a huge role because it's so big and it has so much gravity. It acts like a vacuum cleaner sucking up comets and asteroids that are headed towards the Earth. It protects us from some damaging bombardments. It's really remarkable the things about the Earth that make it suitable for life. In their book, Rare Earth, which is where I got the title of this section of the talk, Peter Ward and Donald Brownlee, again, who are they're not theists, they don't believe in God, they just do science, but they say, if some godlike being could be given the opportunity to plan a sequence of events with the express purpose of duplicating our Garden of Eden, if some godlike being wanted to make our Garden of Eden, our Earth, that power would face a formidable task. It is unlikely that Earth could ever be truly duplicated. So there's probably not, other living creatures like us out there because it's so hard to make a planet like the Earth. So what do scientists say about all these things? About the origin of the universe, the design of the universe, things like the rare earth. Fred Hoyle has a great quote on that. He says, a common sense interpretation of the facts. I like that because I'm a scientist, I like facts. The common sense interpretation of the facts suggests that a super intellect has monkeyed with physics as well as with chemistry and biology, and that there are no blind forces worth speaking about in nature. The numbers one calculates from the facts seem to me so overwhelming as to put this conclusion almost beyond question. What conclusion comes from the facts? That there are no blind forces we're speaking about in nature. Fred Hoyle was an adamant, he passed away, was an adamant atheist. Yet he sees that the universe seems to have no blind forces. Another very vocal atheist was a guy named Antony Flew. Antony Flew spent his entire life one of the biggest promoters of atheism. He wrote about it, he spoke about it. And when he was, I wrote it down, I think 86, he changed his mind, 83 or 86. 81. So when he was 81, he changed his mind. And he became not a Christian, but a deist, someone who believed in God. And the reason was this evidence from science. He says, I now believe that the universe is brought into existence by an infinite intelligence. I believe that this universe's intricate laws manifest what scientists have called the mind of God. This is the world picture, as I see it, that has emerged from modern science. Science gives evidence for God. Can you imagine spending your whole life promoting one worldview? You're known throughout the world for promoting a worldview that says atheism is right. And you have the guts at age 81 to say, you know what? I was wrong. The evidence shows that I was wrong. And I now believe that there is an infinite intelligence, because that's what modern science tells us. So I've actually listed only 3 things. There's other things that give me supporting evidence for some kind of God. The Big Bang origin, which began to be understood in the 1930s, is still being learned about. The James Webb Telescope is telling us things about it. It says the universe had a transcendent origin. The anthropic principle seems to tell us that the universe appears designed for humans. And the rare Earth idea tends to say that the habitable Earth seems rare, if not unique. Now, I began to give talks like this maybe 25 years ago. And if what I'm saying is true, then over time, the evidence should get stronger, because that's what a good hypothesis does. The more you learn, the stronger the evidence. And this is what's happened over 25 years. I've had to throw out things I used to say to try to present the evidence, because it keeps getting bigger and bigger and stronger for these kinds of things. Now, over the last 25 years, people who believe in God, theists, have pointed to these things and said, you know, these point to God. And atheists have got tired of us doing so. So they have begun in the last 10 years to write a bunch of books that try to refute what I've just said. And I firmly believe, as a follower of a God who calls himself the God of truth, that I want to find out what truth is. So the way I have to find truth is I have to read the best arguments against what I believe, as well as the best arguments for what I do believe. And so what I want to do, particularly for you who know some of the arguments against what I've said, is just go through those rather briefly and show why they don't hold up. Why the best evidence still points to God, even though some scientists have done their very best to try to refute that evidence. By the way, there's going to be a time for questions at the end. Do they know how to ask questions? Yeah, okay. So you do it on some app or something. I'm not a millennial, so I have no idea. But yeah, so we will answer questions at the end. So I just want to briefly go through what some of these rebuttals and give you what I think about them. The first one is that we'll talk about the rare Earth hypothesis. The idea is that there are lots of planets out there, so maybe there should be a planet that supports life. Maybe they're common. You'll read that all the time. And the other rebuttal is, well, maybe there are other forms of life. Maybe it's not all carbon-based. So the response is, first of all, there's little possibility of Earth-like planet formed by chance. I'll show you that. And then the second rebuttal is that all life has to be carbon-based, and I'll show you that. So scientists do something we call back-of-the-envelope calculation. It's a rough guess based on everything we do know. And we can do that for the probability of finding an Earth-like planet. We can do a back-of-the-envelope calculation. We know that we have to be in a spiral galaxy. That has a 10% probability. We know that the star has to be in the galactic habitable zone. That has a 20% probability. We know that there has to be tectonic activity. We don't know how many planets have tectonic activity, so we take a guess, maybe 5%. None of them in our solar system have the kind of a tectonic activity that's needed. That's one of the reasons there's no water on any of them. So we make a guess, and we just put the things we know. And this is the partial list of what's required to have an Earth-like planet. Oh, by the way, when you read in science magazines that they found an Earth-like planet, they haven't. What they mean is one of 3 things. The planet might be rocky and not made of gas. Well, Mercury's rocky and not made of gas. It's not Earth-like. Or the planet might be the size of the Earth. Well, Venus is the size of the Earth. It's not Earth-like. Or the planet might be in a place where it orbits the star, its star that has liquid water. Well, Mars is in such a place. So when you read that they found an Earth-like planet, we haven't. We found planets that are rocky or about the same size as Earth or might have water on them. But there's a lot more that needs to happen to have an Earth-like planet. In fact, this is a partial list. This is a more complete list. Okay? And this is still only a partial list because I haven't had the guts to rewrite this, because we keep discovering more things. This list has 322 parameters that are necessary to have an Earth-like planet. And when you do the math, for those who like statistics, including correlations and longevity effects, you find that the maximum number of planets in the visible universe is 10 to the 22. We can only talk about the visible universe, what we can see. The universe does go beyond that. We admit that. But the probability of finding one Earth-like planet formed by chance is 1 part in 282, 10 to the 282. So we have a term in science that describes a number that small. And it's a very technical term. It's ain't gonna happen. So there are many planets in the universe. We're going to find a whole bunch. But it's really naive and unsophisticated to say, well, a lot of them must have planets. That is Stephen Hawking's answer to the planet problem in his book, The Grand Design. Well, there's a lot. He waved his hands. There's a lot. There must be ones that are like, here, but you can do the math. There aren't. The Earth is rare, it's not unique. What about other forms of life? Maybe there are other forms of life other than carbon. Well, what do you need to make life? You need to store information. The reason we can store information in carbon is because it can make long chains of molecules because of the way it binds, and you can store information, RNA and DNA. There's no other molecules that can do that. Silicon has been proposed, but silicon doesn't make life. In fact, here's a great quote. Carbon chemistry is the chemistry of life. Silicon chemistry is the chemistry of rocks. Silicon makes silicon dioxide when it forms with oxygen. And so there is no other forms of life that we can even imagine, because there's no other way to get the information stored that is necessary to create life. It has to be carbon, and carbon has very minute, very specific characteristics that allow us to live in a carbon-based environment. So, in science fiction, you can have any form you want, but not in real life. It's carbon-based. So let's go on to what about the origin of the universe. And there are a lot of different, There are a lot of different proposals. The two main ones are, well, maybe there really was no beginning. And the other one was, well, maybe the beginning was caused by the laws of physics. So let's go through the response to these two. First of all, everything we do know, all the observations and all the known physics, the BGB theorem, the cosmic microwave background radiation points to a real beginning. So all the alternatives are speculative with no evidence. And they all require not just new physics, things we don't know, but things we don't know to be discovered that would actually erase what we do know. They would erase the things that we do know that point to a real beginning in the first moments of the universe. So what has happened is everything we do know points to a real beginning, but we don't know what happened in the first 10 to the minus 32 seconds of the universe. That's a very short time, but to scientists, it's a long time. From the beginning to about 10 to the minus 32 seconds after the beginning, we don't know what happened. So if you don't believe in God, that's where you hide. You say, well, maybe something happened in the first 10 to the minus 32 seconds that means there really was no beginning. I call it atheism of the gaps. Here's a gap in our knowledge. Everything else looks like there's a real beginning and a real beginner. But since I don't believe in a real beginning and a real beginner, I'll fill it with atheism. I'll fill it with the speculative idea that there's no evidence for. None of these speculative ideas satisfy the BGB theorem, which is known physics. And as I said, almost none can solve the entropy problem. And then finally, laws are descriptive, not prescriptive. So let me expand on these a little bit. Alexander Vilenkin was the one who developed the BGB theorem that said the universe has to have a beginning. And here's what he says about it. And by the way, again, he's not a theist. He doesn't believe in God. He said, but the proof now in place, the proof. Cosmologists can no longer hide behind the possibility of a past eternal universe. There is no escape. They have to face the problem of a cosmic beginning. There was a beginning. Where did it come from? How did this universe come into existence from some outside cause because it had a beginning? And one of those causes might be the laws of physics. So there's people who propose, well, maybe the laws of physics have been around forever and they make the universe. But there's problems with that. First of all, laws of physics don't do things. They describe how the universe works. I can write all the equations I want to build a building, how the structure should be supported, but it doesn't build the building. It takes somebody with power and ability to actually construct it. Stephen Hawking recognizes this when he writes this about the laws of physics. Even if there's only one possible unified theory, even if we figured out all the laws, it's just a set of rules and equations. What is it that breathes fire into the equations and makes the universe for them to describe? The usual approach of science of constructing a mathematical model cannot answer the questions of why there should be a universe for the model to describe. Why does the universe go to all the bother of existing? The rules and the laws don't make it exist. You still have to do that somehow. And Alexander Vilenkin realizes that even the laws themselves require an explanation. He says the description of the creation of the universe from nothing is given in terms of the laws of physics. That makes you wonder, where are these laws? If the laws describe the creation of the universe that suggests they existed prior to the universe. The question that nobody has any idea how to address is where these laws come from and why these laws in particular. And I would actually debate with him. I think there are some of us who do have some idea of where these laws came from and why these laws in particular. Finally, let's talk about design and fine-tuning. What do people say about this? Well, there's two major proposals. The first is that we live in what's called a multiverse, and you're all familiar with this because Marvel has made a bunch of millions of dollars based on the multiverse idea. And the idea is that there are other universes out there that Spider-Man inhabits and Doctor Strange inhabits and all those things out there somewhere. And that most of them can't support life, we just happen to live in the one that can. There are other people that just say there is no fine-tuning. We just think there is, but there isn't. So how do you respond to these? First of all, there's no evidence for multiverse, despite what the movies say. There may be a multiverse out there, but we don't know if there is. There's no evidence for it. There may be no evidence. How do you talk to another universe, right? And so it's speculative, and there are many multiverse models, and many of them still require fine-tuning. Only certain of them allow different laws of physics in different universes. The many worlds interpretation of quantum mechanics is a multiverse model, but the laws of physics are the same in every universe. So that doesn't help. And then fine-tuning, what I've talked about, is actually based on science, while other ideas are not. They're based on speculation. But let's play the game a little longer. What if we would find a multiverse? Would that affect this evidence for God? And would that solve the fine-tuning problem? And to be honest, the answer is quite complicated. Why? Because it depends on what model of the multiverse we have. If we actually discovered a multiverse, we would do the math, we would understand it, and then we could make predictions. But only a few of the multiverses, the universes, would support life, so we still live in an improbable one. The laws of physics may actually require a multiverse if we're to have any planet that have complex life. If the universe is built on string theory, which is one proposal, then maybe to make a single universe, you need to make a multiverse. So the multiverse may actually strengthen the case of God. Whenever we make a new discovery over the last 25 years, it's actually strengthened this evidence for God. If we find a multiverse and understand it, I would predict it would do the same. And then finally, how many universes would an infinite God create? An infinite God is nothing to create one. Why not create a multiverse? Suppose God is sitting up there and goes, I want to make a planet with humans on it. I'm going to base it on string theory. String theory requires me to make 10 to the 500 universes if I want to make one that has life in it. No big deal. I can make 10 to the 500 universes. Right? So I don't know. The idea that I can hide behind the multiverse and say, here's an idea with no evidence and it takes care of the fine-tuning problem is not a very smart way to live, to be honest. And then fine-tuning is scientific. The other ideas are not. Luke Barnes and Grant Lewis wrote a book called A Fortunate Universe, and they say this reaction against fine-tuning might stem from the belief that fine-tuning is the invention of a bunch of religious believers who have hijacked physics to their own end. This is not the case. The field of fine-tuning began in physics journals and remains with physicists. They go on to write, while there is more work to be done, physics has tended to consolidate our understanding of fine-tuning. This is a really good book. I don't recommend the cosmological entropic principle. I do recommend A Fortunate Universe. Luke Barnes and Grant Lewis are two Australian astrophysicists. Luke Barnes is a Christian, Grant Lewis is an atheist. And they both agree that the universe looks fine-tuned. 2/3 of their book goes through why there is no doubt that the universe is finely tuned. And the last third of their book is fascinating because they have a dialogue between someone who believes in God and someone doesn't as to what's the best explanation for the fine-tuning. Is it God or is it a multiverse? And you can make a decision for yourself. I think, and others who have read the book agree, that Luke Barnes' argument for God as the reason for the fine-tuning is much, much, much stronger than Grant Lewis's idea that the fine-tuning comes from a multiverse. But the fine-tuning is real, and you have to explain it somehow. The universe is finely tuned to allow humans to exist. So when I look at the evidence, what conclusion do I come to? When I look at all the evidence, I need to find an explanation that fits all the evidence. Not just fits this little piece, not just the origin, not just the design, not just the rare earth, but that fits it all. And to me, the explanation that best explains it is that there is a transcendent, intelligent designer and creator who has a purpose for humanity? Why did he make a planet that we could live in if he didn't have a purpose for us? But it's not just me that thinks that the universe even says it has a purpose for humanity. I want to quote Paul Davies. Paul Davies, when he wrote this, was agnostic. I think he's become a theist, actually. And he makes this remarkable statement. I mean, this to me blew me away when I read it. He says, if physics is the product of design, the universe must have a purpose. And the evidence of modern physics, look at that statement. The evidence of modern physics suggests strongly to me that the purpose includes us. He looks only at physics as an agnostic physicist, and he says it's clear from modern physics, if the universe is designed, that we have a purpose. Now again, as someone who believes in God, this isn't startling to me that science has stumbled upon this conclusion. King David wrote about 3,000 years ago the same question. He was an amateur scientist. He looked at the heavens and studied them. And he said, when I consider the heavens, the work of your fingers, the moon and stars which you have set in place, which God made, what is man that you are mindful of him, the Son of Man that you care for him? How is it that this deity who can make a universe like ours cares about humans? But yet, that seems to be what the evidence points to. Now, there are scientists who've looked at this evidence and become Christians because of it. Alan Sandage is one of them. He wrote, "It was my science that drove me to the conclusion that the world is much more complicated than science. It is only through the supernatural that I can understand the mystery of existence." And George Greenstein, writing about the whole aspect of what we've talked about, the universe, the design, etc., he says, as we survey all the evidence, the thought insistently arises that some supernatural agency, or rather agency with a capital A, must be involved. Is it possible that suddenly, without intending to, we have stumbled upon scientific proof of the existence of a supreme being? Now, I don't think you can prove God through science, so this agnostic scientist makes a stronger statement than I would. But I do believe that what we have learned from science gives abundant evidence for the existence of God. But not just a deistic God, not just a God who made the universe like a clockmaker and set it to run, but a transcendent, intelligent designer who created the universe and has a purpose for humanity, which is exactly how the Bible describes the God who supposedly made the universe. So to me, the evidence of modern science comes to this conclusion, that it points to the fact that there is an intelligent designer who's outside of space and time, who made a universe and has a purpose for humanity. I just barely touched on this. I've written a book on this. I have a Facebook page and a bunch of junk like that if you have more interest, you can go look at this stuff. And now I think we will stop and spend 15, 20 minutes for questions.